Hey everybody, this is Moballer12 here to help quench that knowledge thirst. For this video, I'll be specifically talking about esters. This is a continuation of my discussion on acid derivatives. The only two other acid derivatives that are left are the amides and nitriles, and basically that will conclude my discussion on acid derivatives in whole. Then the course of the videos that I'll be uploading will be alpha alkylations, alpha halogenations, aldol reactions, Claisen reaction, Michael reaction, all that good stuff. And that will basically conclude the videos on organic chemistry 2 topics. I think that basically touches on a majority of those OChem 2 topics. Then I'll revert back to OChem 1 and make videos on SN1, SN2, E1, E2, all that good stuff, okay? So that's basically the course of the videos that I'll be uploading in regards to organic chemistry. Also, quick little heads up, again, Facebook fan page, link in the description box below. Show your love and support. Tell your friends and family about it. Like the fan page. Let's see. Also, feel free to ask your specific questions in regards to the new series. If you don't know what I'm talking about when I keep saying new series, I'll put a link in the top right corner. It's a video that basically explains this new series that I'm working on, so feel free to check it out. The video is called Quickie Update. So that's pretty much it. So let's get started with our discussion on esters. Okay, there's 5 reactions you guys need to know. Obviously there are more reactions, but these are the most important ones that we will look at. Some of these reactions are repeats from previous discussions I've had on esters. Okay, so let's start with this ester topic. Again, ester takes the structure I've shown here. You have a carbon group attached to an oxygen, and you have a carbonyl here, and you have another carbon group there. That's the basic form of a ester, okay? And the things that I've put in brackets are basically going to be your leaving groups, and they're going to form alcohols. Now, the type of alcohol you form is based on what type of R group you have here. So again, these R's in the starting material represent carbon groups. So if you have a primary carbon here, you'll form a primary alcohol. If you have a secondary carbon here, you'll form a secondary alcohol. If you have a tertiary carbon here, you'll form a tertiary alcohol. So I want you guys to realize that. So again, each and every one of these alcohols that you produce can be either primary, secondary, or tertiary. Something extremely important to realize. Okay, so again, just a brief little discussion on primary, secondary, and tertiary alcohols. Here's a primary alcohol because this carbon directly attached to the OH group is a primary carbon. It's attached to one other carbon group. This alcohol here is a secondary alcohol because the carbon directly attached to the OH group has only 2 other carbon groups attached to it, making it secondary. And finally, this is a tertiary alcohol because the carbon directly attached to the OH group has only 3 other carbon groups attached to it, therefore making it a tertiary alcohol. So tertiary, secondary, primary, those are some examples. So let's begin with the reactions. Again, I'm not going to talk about the reaction mechanisms because that's not the point of this video. I want to just show you guys how to go from starting material to product. Hopefully in the near future I'll be making videos on the reaction mechanisms, okay? So again, the things in the brackets are your leaving groups and they will make alcohols. So the first reaction we have is a ester reacting with H plus and water, or OH minus and water. So basically you react the ester under acidic conditions in the presence of water, or basic conditions in the presence of water. It's either or. You'll generate the same product, but it will take a different course of mechanism. Okay, and the product that you'll form, again, will form our alcohol from this piece. We'll form our alcohol from that piece. It will be OH R. Okay, and the other product we'll form, all you have to do is attach an OH group to this carbon of the carbonyl, so you form a carboxylic acid. So you form those 2 products, okay? So you form a carboxylic acid and an alcohol. Now we don't know if this is a primary, secondary, or tertiary because I'm showing you a very generic form of the reaction, but nonetheless this could be easily a primary alcohol or secondary alcohol or tertiary alcohol. And again, all you have to do to draw the carboxylic acid, again, this is going to be your leaving group, so all you have to do is replace this piece in brackets with an OH, and that's what we did here. Excuse me. So that's the first reaction, nice and simple. The second reaction is you have an ester reacting with a amine, okay? So second reaction, let me zoom in on this a little bit so you guys can see this. Hold on one second. Second reaction is you're reacting a you're reacting a ester with a amine. So again, it's a very simple reaction. All you have to do is replace this OR group, which will become your alcohol, with the piece I'll have in brackets right here. So like the other videos I've talked about on amines, the reagents specifically, the R prime and R double prime can be an H or a carbon group. So I want you guys to realize that, and that specifically applies to this reagent, okay? And that's pretty much it. Again, replace this OR group, which will become your alcohol, with this piece I'll have in brackets, and you'll form your amide plus your alcohol. So here's your not carboxylic acid. You form your amide. Right? Again, OR group gets replaced by this piece here that I have in brackets. You lose an H through the course of the mechanism. And the final product you form is a alcohol. So again, this alcohol can be a primary, secondary, or tertiary alcohol. It doesn't really matter, but just realize that it could be one of those types of alcohols, okay? So moving on to the third reaction, we have an ester reacting with a lithium aluminum hydride in the first step, and then second with a H+ workup step. Again, this is a neutralization step. I've talked about the specific reaction in a video I believe called the reduction of carbonyls. I'll put a link in the top right hand corner so you can check that video out. I talk about the reaction mechanism and all that good stuff if you want to look at it more in detail. So again, I believe the title of the video is called the reduction of carbonyls. So again, what happens is, again, your leaving group forms your alcohol, which can be a primary, secondary, or tertiary alcohol. So let's put that down here. So you form one alcohol, which could be a primary, secondary, or tertiary alcohol, and the other alcohol, the other thing that you form from this reaction is a primary alcohol. And the reason why I put this in brackets is this specific piece right here of the ester, which contains a carbonyl, which contains a carbonyl, is going to be your primary alcohol. If you see in this case, I always say that this could be either a primary, secondary, or tertiary alcohol, but in this case it's always going to be a primary alcohol. Now what happens is that lithium aluminum hydride, which is the source of hydride ions that take the form of this here, lithium aluminum hydride is the source of 2 hydride ions, and basically through the course of the mechanism, these hydride ions add into the carbon of the carbonyl and reduce the system to a primary alcohol. And in order to draw the product from this step, is all you have to do, again, once this piece is broken down the middle, okay, so all you have to do is cleave this bond down the middle between the carbon of the carbonyl and the oxygen of the soon-to-be alcohol. Cleave that bond down there. One piece is going to be this piece here, which I've already drawn there. The other piece is this piece right here. In order to draw your alcohol, your primary alcohol, from this piece, all you have to do is erase one of the bonds from the carbonyl and add an H to the oxygen. Again, all you have to do in order to draw your primary alcohol, which is your product from this, is one of your products from this reaction, is erase one of the bonds from the carbonyl and add an H to the oxygen. Okay, nice and simple. If you want a more in-depth explanation of this reaction, again, check out that video that I already put a link to. So again, that's how you form the primary alcohol aspect of it. So it will look like this. There's your primary alcohol, and this carbon right here is that carbon right there, and that was your carbon of your carbonyl. So then now you have 2 H's attached there, and those are the H's that were sent from the lithium aluminum hydride to help reduce the system. Again, if you want a more in-depth explanation and you want to look at the reaction mechanism, check out that video. I already put a link to it. The fourth reaction, nice and straightforward. All you have to do, again, you form your alcohol from this piece right here. Looks like that. And all you have to do is replace this piece and replace it with a H to get your other product, which is a aldehyde. Again, diol H is a source of 1 hydride ion. Lithium aluminum hydride was a source of 2 hydride ions. This guy is a source of 1 hydride ion, and this 1 hydride ion attacks the carbon of the carbonyl, reduces the system in such a way where through the course of the mechanism you're going to form an aldehyde, and that's what you do here. And as a part of the process, you kick off this piece here, this leaving group, and you form your alcohol. The first step of this reaction mechanism is very similar to this reaction mechanism we have here. If you want to understand how this reaction works, understand the first step of this reaction mechanism. And if you want to understand the first step of this reaction mechanism, check out that video that I already put a link to. And that's it. Again, all you have to do is replace this OR group with a H, and you get your aldehyde and your alcohol. And in the final reaction, our fifth and final, we have an ester reacting with the Grignard reagent. Okay, we have the first step, which is the Grignard reagent reacting with this ester, reducing the system. And then the second step, we have this neutralization step. Okay, I do have a video discussing this specific reaction. It's called the Grignard reaction video of mine. I'll put a link in the top right hand corner. Check it out if you want a more in-depth explanation of that reaction mechanism. But nonetheless, the Grignard reagent basically sends this R group twice. 2 R groups that act like nucleophiles will attack to the carbon of the carbonyl. So this piece here that I'll put in brackets will be one of your products, and this piece right here will be one of your other products, right? That makes sense. And again, you always form your alcohol from the leaving group. If you remember from the third reaction, I said you form a primary alcohol always, and there's our primary alcohol. And in the case of this reaction where you have this ester reacting with the Grignard reagent, instead of forming a primary alcohol, this piece will always form a tertiary alcohol. Okay, again, this piece right here that I have in brackets will always form a tertiary alcohol. And again, if you want a more in-depth explanation of the reaction mechanism, check out that video that I put a link to. It's called the Grignard reaction. But nonetheless, this R prime, which is a carbon group, will attack twice to this position here. So effectively, you'll have this, okay, R prime, R prime, okay. So 2 of these guys will attach to the carbon of the carbonyl. All you have to do to finish drawing the product is erase one of the bonds from the carbonyl and add an H there. Okay, so that's what we're going to do. Erase one of the bonds, add an H there. And there's your tertiary alcohol. So realize that you always form a tertiary alcohol in the case of reaction number 5, and you always form a primary alcohol in the case of reaction number 3. Okay, and that pretty much concludes my discussion on esters. So stay tuned to the second part where I do a bunch of examples.